Hello everyone, welcome to Technologies Discussion Channel. Today, I'd like to start a new topic of discussion which is on digital modulation. There are actually two parts on my discussion for this video. Okay, the first part, I will discuss why there is a move from analog to digital signal. Okay, so in fact, most of the signal, for example, my voice to this video, they are actually analog in nature. Okay, so over this video, you will understand why there is a need to move from analog to digital. The next portion of my discussion will be on the throughput. Okay, so how can we actually describe the throughput using bit rate, using symbol rate or baud rate, and also data rate, and last but not least, channel rate. This is how we can actually describe the throughput. Okay, but the throughput is still the same. It's how we express the throughput in different form, as you can see from here. This will be the part one series discussion on digital modulation. So guys, if you're keen to know more about digital modulation, okay, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on digital modulation. This is my email. If you have any question regards on this discussion, okay, please drop me an email. Okay, or if not, if you want to have a faster response, you are always welcome to ask me your question through the comment. Before I continue, I'd like to urge you guys to help this channel by press the like button. Guys, it's free and just a few seconds. Help me press the like button now. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Let's quickly take a look why we need to move from analog signal to digital signal. Okay, so you can see that the tedious, okay, as I explained earlier on, most of the signal, okay, in fact, can be analog in the nature. Okay, why we need to have a to D converter and also later on D to A converter. Okay, so this video I will explain why there is a urge to move from analog to digital conversion. The analog to digital conversion, in fact, play a critical role in the world that we actually live in today's. Most signal, for example, the song or as I mentioned, the speech, okay, they are all analog in nature. However, if you want to transmit them globally to multiple people simultaneously, or even to enhance their quality by remove away the background noise, okay, you will need to convert them into digital form. Then you can do all this. So after you have removed all this to the digital form, you can then convert them back to the analog. So basically, these are some of the key reasons, okay, why we need to move the signal from analog to digital. The first one will be the accuracy and also the precision. Okay, firstly, the digital data is actually less prone to noise and degradation as compared to analog signal. Okay, so as you can see from this two diagram here, because this is an analog signal, as you can see that this is actually signal plus noise. Okay, you can see that the noise is actually add into the original signal, and this can become a big issue. Again, from here, you can see that this is a digital signal. Again, you can see that noise is actually added to the digital signal. However, for digital signal, we will recognize this as 0, 1, 0, 1, 0, 1. Even noise added onto the original signal, I was still able to identify this as a signal 1 and this as a signal 0. So hence, noise doesn't play any critical role in terms of the digital signal. Okay, so this is what I mean here. The analog signal can be affected by the interference, which often led to a loss of quality. However, okay, for digital signal, they can be clean and correct using error detection and correction algorithm that ensure their high accuracy and also the precision. Okay, so this is the first reason why we need to move from analog to digital. Next, okay, so the storage efficiency. Okay, so basically it will be much more easier to store a digital signal. Okay, so you can recall that okay, it almost very difficult to store our so-called conversation, for example, in an analog way. However, if we are able to convert them into a digital way, like for example, WhatsApp call, it will be much more easier to save our conversation. Okay, so basically the second reason okay, is because for easy storage. The digital data can be compressed and store more efficiency as compared to the analog data. Okay, so this actually allows for more information to be stored in less space, whether on a physical medium like hard drive or in a cloud storage. Okay, so basically this is the second reason. The third reason is because of the ease of manipulation. Okay, again, this is basically the bad point of digital data. The digital data can be easily manipulated, processed, and basically analyzed using computer. Okay, so this is critical for tasks ranging from simple data editing to complex data analysis and also machine learning. Okay, so this can be the advantages and also the disadvantages for digital data. In short, okay, we can easily manipulate the data, and basically based on our manipulation of the data, we can do some data analysis and also some machine learning to process the data. However, this can be also a big issue once we can easily manipulate the data. Next, on the transmission quality, digital data can be transmitted over longer distance without significantly loss of quality. Okay, so this is because digital signal can be regenerated and amplified without introduce noise, unlike analog signal, which can be degraded over distance. Let me explain this. For example, this is an analog signal. If we send it over a long range, you can imagine the signal becomes smaller and smaller, and there's no way that we can so-called amplify to regenerate back the original signal. However, for the digital signal, again, we are going to send this over a long range. Again, the signal will be again reduced. You can imagine this. However, we are capable to so-called re-establish the signal. For example, let's say it didn't really go to the zero. Let's say instead of 5 volt, it goes to, let's say, 2 volt. Again, with this so-called digital data, we can send this 2 volts back all the way to 5 volt again, and we can actually retransmit this. Okay, so basically this is the meaning of this transmission quality. Okay, for relay, okay, it will be very challenging to relay back the original analog signal, but for digital signal, it can be easily done so. Next, okay, the integration with modern technology. Okay, so nowadays, the modern technology, okay, for example, the internet, smartphone, or computer, they are mainly digital data. So hence, in order to integrate with all this, it will be easier to convert the analog signal into digital signal. So basically, this is what I mean. Converting the analog data to digital assure compatibility with this technology. Hence, they enable seamless integration and communication. Next, in terms of security, okay, the digital data can be encrypted and also secure more effectively as compared to the analog data. Okay, so this is critical for protecting sensitive information in an era where data breach and cyber attack they are very common. Okay, so this is the reason number 6. Reason number 7, okay, the searchability and accessibility. Okay, so digital data can be indexed and searched easily. Okay, so making it more accessible. Okay, this is particularly important, okay, for large data set where quick retrieval of information is necessary. Okay, so this is reason number 7. Okay, I have 10 reasons. Let's come to the last 3. Okay, so basically in the longevities and preservation, digital data can be copied and backed up without loss of quality. Ensure that this is forever. Okay, for example, we can copy digital data. Okay, for example, as long as I have this digital data, okay, I can reproduce it even after 10 years, 20 years, 50 years, etc. But for analog, okay, it may have some issue. Okay, so analog data, on the other hand, degrade over time and with each copy. Okay, so imagine this. For example, if a picture, okay, which is analog, which means that the picture in an analog sense, they may degrade after several years. However, if we have a picture in terms of digital sense, we can still ensure the same quality of the picture as long as we have the original data. Cost efficiency. Okay, over time, the cost of storing and also transmitting digital data has decreased significantly. Okay, so therefore, the digital storage medium and transmission method are generally more cost effective than their analog counterpart. Okay, I still remember, okay, in the very early days, okay, 1 gigs of storage data is amazing. Now we have even 1 T storage data. Okay, because over time, okay, the cost that we actually store our data, they has decreased significantly. So therefore, the space to store the data become explosion. Okay, we can even store more and more data in this kind of storage process. Next, on the interactivity and also the user experience, digital data actually allow for interactive and also dynamic user experience. Okay, for example, digital medium can include interactive element, hyperlink, and also multimedia content that hence enhance the user engagement. Okay, so these are the 10 reasons why the analog need to be moved into the digital way. Okay, so in summary, converting analog data to digital format actually enhance accuracy, efficiency, security, and also compatibility with modern technology. Hence, this is necessary in this current digital world. Next, again, before I continue, guys, if you find this video helpful, okay, I urge you to help this channel by press the like button. For those who have learned something from this video, please consider to subscribe and turn on your notification bell. I will move on to the second portion of this video, is to describe the throughput, okay, in terms of bit rate, in terms of symbol rate, and also data rate and also channel rate. Okay, let's take a look on the bit rate first. Okay, so what is bit rate? Okay, bit rate actually refers to the numbers of bits that are processed or transferred per unit of time. Okay, typically measured in bits per second. Okay, so it is commonly used to describe the quality and also the speed of data transmission or process in various contexts. Okay, let me say in a very simple word. Okay, so for example, bit rate actually describe how many numbers of bit that we are able to send over from the transmitter to the receiver. Okay, for example, in every second, okay, we can describe how many bits can be sent in every second, so as we know how much data can be actually sent from the transmitter to the receiver. Okay, so basically this is what I want to say. When we actually transfer the information, we call this bit rate. So since this is a digital signal, okay, or digital data, so hence all these bit rate are represented by either 0 or 1. For example, okay, we say that we can send this amount of data in 1 second. Okay, let's do a very simple example. Nowadays, these numbers of bit can be in terms of millions. Okay, but I cannot afford to explain in terms of millions of bits. But let me just give a very simple illustration to let you understand what is bit rate. Again, let me say this again. So for example, I can send this amount of data in 1 second. So how can I actually quantify this? I will count the numbers of bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have count. This is actually 12 bits. So in short, I can actually quantify this as 12 bit per second. So basically, this will be the bit rate. I can send actually 12 bits of data in 1 second. So basically, this is an example. Okay, if 12 bits of information are sent every second, then I can say that the transfer rate is actually 12 bits per second. Basically, in short, in 1 second, I can actually transmit 12 bits of data. Okay, so basically the unit of measure is actually called bits per second. Okay, as you can see from here, this is bit per second. Next, okay, let's move on to the symbol rate, okay, which is also known as the baud rate. Okay, the symbol rate, also known as the baud rate, actually refer to the number of symbol change, okay, the signaling event transmit per second in a digital communication system. Okay, so it is measured in symbol per second. Okay, so don't worry so much on this first. Let me explain all this before I come into the example to let you understand what is called a symbol rate. Coming to a key point here. Okay, so the symbol. Okay, so a symbol actually represent either at least one or more bits of data. So basically in short, okay, one symbol can be equals to 1 bit, or one symbol can be represented by more than 1 bit of data. So this is what it means. So all these actually depend on the modulation scheme that we actually use. For example, in binary BPSK, okay, so each symbol actually represent 1 bit. Okay, while in QAM, okay, so basically a single symbol can be represent multiple bits. Okay, so again, if you want to know more this, you can always look at the playlist to understand this better. Okay, but for now, I'm not going to concentrate on this, but I just want to quickly explain what is symbol or baud rate here. So what is the relationship? Okay, what is the symbol relationship to bit rate? Okay, so the bit rate, okay, that we illustrate earlier on, which is in bits per second, they are actually highly related to symbol rate. Okay, so basically this is governed by the equation here. Okay, for example, the bit rate, okay, basically will be equals to the symbol rate multiplied by log 2 over m. Okay, but in short, you can take this as k. Okay, so k, okay, for example, m equals to 2 to the power of k. K is the number of bits. Okay, so you can represent this as k, okay, which I will explain later on. Okay, so if you we so-called put this symbol rate on the left. Okay, so this will be another set of equation. So in short, if I need to know the symbol rate, I just need to take the bit rate divided by the numbers of bits that is actually represented by the symbol. I will be able to know the symbol rate. If I want to know my bit rate, okay, I will take my symbol rate multiplied by the numbers of bit, then I will be able to know the bit rate. But don't worry, on my next slide, I will explain this. Okay, so this is what I mentioned earlier on. So these are the 12 bits that I can send in 1 second. So therefore, I call this 12 bits per second, if you still remember. Okay, so this is what we call a 12 bits per second. So now I like to explain what is symbol rate. Okay, so what is symbol rates? For example, now, as I mentioned earlier on, okay, the bit rate is actually 12 bits per second. So now, for example, I say that one symbol is actually equals to 4 bits. Okay, so what does this mean? Okay, again, these are all 12 bits here. So I need to represent, okay, 4 bits into one symbol. So this is one symbol, this is second symbol, and this is 3 symbol. And with the same so-called describing in terms of throughput, I can actually describe this as 3 symbol per second. Okay, you can take a look over here. The amount of data that can be sent is still identical. Okay, so I can describe them either as 12 bit per second, which is the bit rate, or I can describe them as 3 symbol per second. So over here, you can see that I never change the throughput, but I actually change the way how I describe the throughput, either in terms of bit rate or in terms of symbol rate. Okay, so now with this, you will be able to do a very simple conclusion. Okay, so for example, when one bit is represented by one symbol, which means that these are all the bits, and let's say one bit is equals to one symbol, then the symbol rate will be the same as the bit rate. Okay, so I guess you can see from here, okay, one bit is equals to one symbol, so basically bit rate will be equals to the symbol rate. For example, for this case here, 12 bits per second will be equals to 12 symbol per second because one bit is equals to one symbol. However, for this case here, let's say 2 bits actually represent one symbol. Okay, then the symbol rate will be half of the bit rate. Okay, so which means that every 2 bit they will become a symbol, and you can see that 12 divided by 2, which is 6 symbol per second. So this is what it means here. So the four bits made into one symbol is illustrated over here. So with this, I think you will be better positioned to understand what is symbol rate. So please don't be very so-called confused. Okay, so we describe the throughput can be described in terms of bit rate, can be in terms of symbol rate. We does not change the throughput, but we just express in a different way to describe the throughput. Next, okay, so this is what I want to say. So next, let's come to the quick example. Okay, how can we do a very simple calculation here? A mobile radio can actually support a data rate. Okay, so data rate can be also bit rate for this case here, 16 kilobits per second. Okay, we deem a bandwidth of 25 kilohertz by encoding 2 bits in each symbol, which means that one symbol they actually has 2 bits. So this is the information I can extract here, and the bit rate is 16 kilobits per second. Okay, so what is the bandwidth efficient? Okay, so I have not described what is bandwidth efficient. Okay, I will quickly explain what is bandwidth efficient over here of the radio link and what will be the symbol rate. Let me start off by explaining what is bandwidth efficient. Okay, so bandwidth efficient is basically a measure how efficient, okay, a given bandwidth is utilized to transmit data. So basically, it is calculated as a ratio of the data rate over the bandwidth. So basically, in short, for example, for this case here, how much bandwidth I need to send this amount of data. So how efficient will it be? So therefore, we call this a bandwidth efficient, which is data rate over bandwidth. Let's say the amount of data or maybe the amount of bandwidth that I need actually reduce, which means that I actually have a better bandwidth efficient because I need lesser bandwidth to send the same amount of data. If you understand this, I need Okay, for example, I can have lesser bandwidth, but I still can send the same amount of data, then I will have a better bandwidth efficient. Okay, so basically this is a formula to calculate the bandwidth efficient, which is the data rate of the bit rate over the bandwidth. Okay, so the question already given to me, the data rate is 16 kilobits per second. The amount of data, the amount of bandwidth, sorry, the amount of bandwidth to transmit is 25 kilohertz. So from here, I can compute that this is 0.64 bit per second per hertz, which means that every hertz I can send this amount of data. In short, every hertz, the bigger the number of this bit per second, then the better will be the bandwidth efficiency. Okay, so basically this is what is bandwidth efficiency. Okay, so next come to the essential of this discussion, which is the symbol data. Okay, so what will be the symbol rate? Okay, so it can be bit rate, it can be data rate divided by K. Okay, I like to say that K is the number of bits that so-called can be represented. Okay, for example, here, one symbol is equals to 2 bits. So basically, this will be equals to 2. And the total bit rate is so-called to send is 16. So basically, from here, I can compute that the symbol rate is 8 kilo symbol per second. Okay, I think you should be able to get this now. Okay, so basically, it means that 1 second I can send 16,000 numbers of bit. So now I mentioned that every symbol will be 2 bits. So basically, you can imagine that 16 divided by 2, which means that I'm going to have 8 kilo symbol per second. Okay, so basically, I describe the throughput is still the same. I can describe in terms of data rate or bit rate, which is 16 kilobits per second, or I can describe them in terms of symbol per rate. Okay, so basically, I hope you have a better understand what is symbol rate. Next, let's come to the data rate with channel rate. Okay, so basically, let's quickly understand this. For example, okay, when data rate is equal to bit rate, for example, this is our router which having one channel. So which means that the data rate will be the same as the bit rate, which is 12 bit per second. Okay, remember earlier on I did mention that let's say we can send this 12 bit of data. So basically when data rate which is equal to the bit rate, we call this 12 bit per second. So now imagine, okay, instead of one channel, we have three channel. Okay, so instead of one channel, we have three channel, which means that the amount of data or data rate actually increase. Okay, so basically the data rate, okay, so basically this is the bit rate of every channel. Every channel I can actually send 12 bits per second. So basically now I ask you, what will be the data rate of this so-called router? Then you can easily do this data rate of this so-called router will be 12 multiplied by 3, which means that the total data rate will be 36 bit per second. Okay, so basically with this video here, I actually describe what is bit rate. Okay, so basically, what is bit rate? Let's say we have one channel, so data rate will be equals to bit rate, which is equals to 12 bit per second. So now, okay, this actually instead of one channel, it become three channel. So I need to take the numbers of bit rate, okay, per channel, multiply by the number of channel, which is 36 bit per second. Okay, so with this, okay, I hope you have a better understanding how can we actually describe the throughput. Firstly, by using the bit rate. Okay, second, by using the symbol rate. Third, in terms of the channel. Okay, then we will be able to describe the data or the throughput in data rate. Okay, so with this, I'd like to end my discussion. Please help to like, okay, and subscribe. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.